Before I start, I just want to say very happy to be at JFocus this year. And I was able to meet two really awesome people who were really interested in this Kubernetes Raspberry Pi thing. And they're actually in the conference. I don't know if they're in this room right now. But we have Laura, who does a lot of crazy things with it. And we have Pence, who actually created some of the best 3D printed stacks of a Raspberry Pi cluster. And I was so happy to see them in this conference, and extremely happy to be here. If you get a chance to catch them, do say hi and learn about all the cool things that they do. And yeah, so let me get started. My name is Ray. I'm a developer advocate for the Google Cloud Platform. I love to bring our technologies, open source and the cloud technologies, to developers all over the world. If you'd like to chat, or if you have any feedback, thoughts, ideas, anything, questions, please contact me on Twitter at Saturnism. Okay, and I love to write programs. I love to write code. I was also doing a lot of different things, from coding to architecting solutions and managing projects. But my other passion is traveling, and I love to take photographs. So today we're going to talk a little bit about gRPC, about why is it important. I know that microservices is probably on many people's minds right now. I'm not here to tell you whether you should or shouldn't be doing it, right? That's a whole other theory. And just the takeaway here is, whatever you do, do it for a purpose, do it for a reason that solves a problem, right? But one thing I did observe is that if you are already writing a monolith of some sort, and you're trying to break it up into microservices, or if you're looking into writing distributed systems, you have to consider the consequences, right? For example, every one of the service you have to manage, you have to deploy, you have to be able to have good DevOps practices around it, right? That could be more overhead in a way, right? You need to consider more tooling or more automated ways to deal with the more and more instances and complexities that you might actually encounter, right? Even though it helps you potentially drive velocity, but you have to consider many other things. And one of the things that I observe is that what people usually don't ask or don't consider is, well, how are you going to communicate between the multiple services you have? By default, we kind of fall back to, let's use JSON over HTTP or REST in a way, because that's what everybody is doing right now. But that kind of reminded me of many years ago, we had this thing called SOA as well, right? And what was the default messaging for that, right? That was SOAP and whistles and all that. But then we also ran into some issues with it, as you may have went through already. And I just want to put something else out there for you to consider and check out, and compare it and see if that helps you to resolve your problems. So what is gRPC, and what is RPC anyways, right? Does that sound familiar? Has people been using RPC for a long time? Yes. Anybody here remember Corba? Use Corba? Wow, many hands. I feel so bad. DCOM, anyone use DCOM? Wow. Yes, many of those, right? So this is what I did when I was doing a research on this topic, because I have used many of these technology before, including Corba, and I forgot how to write it, so I had to look it up. And this is a great tutorial that I found on the internet. It's like the first link if you type Corba tutorial, and and it's a really good tutorial. If I ever need to write Corba again, this is where I'm going to go. But with any RPC framework, you're going to have some kind of IDL, right, like an interface definition language. Why? Because most of the RPC frameworks will compile and generate stub code for you into different languages, so they are interoperable. And so you need an intermediate language to help you to do that, right? So many of these RPC framework has some kind of IDL, and this one looks pretty simple. You define the method, you can add two numbers together. Great. And then, how do I implement it, right? Usually, these types of RPC framework will generate the stuff for you. All you have to do is extend it or implement it. So here, I think the tutorial says, add two numbers together, return it, perfect. And then I'm like, how do I implement the server? This is just trying to add two numbers together, right? And then I'm like, okay, I don't know what these are, so I cannot give up, right? And I think that's what and why RPC potentially has had some bad reputation in the past, right? And then I'm like, okay, now I go to the servers and let me do the what do you call it? The clients, right? And it's a lot simpler, but still, like naming context and narrow and all that stuff, it gets a little complicated. And then what did we do? And then we had RMI, right, which is great for Java. You are able to write and define your interface in Java. You are able to export it on a server, and you can connect it, and you have all the serialization, externalizables, all you want. And what's the problem with RMI? Potentially, it's not interoperable with other platforms you're trying to use or connect from, right? It's really easy to use, but not very interoperable. And then we had even better idea. You can see where the question marks go, the last one, which is SOAP, right? So we say, hey, why don't we have an interchangeable format that's machine understandable and also human understandable, kinda, and let's use XML, right? And then we use SOAP, which you can use RPC style SOAP or document style SOAP, right? So you can pick and choose between the different styles. But what's really nice back then also is you can generate, hopefully you're generating all of these things automatically, not handwriting them, right? And then on the other side, you can generate the clients as well. Moving forward, we actually have now using REST, right? But if you think about REST or RESTful calls, we still have some kind of transport mechanism. This JSON, this text-based format, right? We think that XML is too slow. Well, guess what? I think all of the text-based messaging are going to be too slow at some point. And what's more is, we run into issues with, well, how do I generate the client library? Do I have to rewrite this every single time? And so we still need some kind of definition language around the services that we are trying to consume. So we have now Swagger to do that for RESTful services, right? So everything is kind of coming back around and around over and over again in a way. So why RPC, though? Why are we talking about RPC? Why should you actually consider it? Well, first of all, the strong typing that you get, which is something I love as a Java developer. I cannot ever write a nice program in Java in first place, but I can even write less of them in non-statically typed languages, right? I don't want to mention names, but I think it ends with scripts most of the times, right? So, with the RPC frameworks, usually you're able to generate these strongly typed objects that you can safely consume and use on both sides of the client and server. It's generally more efficient because they're usually binary. But the real thing here is like it really helps you to solve some of the problems that you wouldn't be able to do, or it will be harder to do if you are using a RESTful protocol, right? What I mean by that is in REST, most of the operations is based on the HTTP verb, which is the get, the put, the patch, the delete, right? And all of these things are mostly CRUD. Now, what if you actually have a complicated business process, a business operation? For example, transfer money from account A to account B. It will be a little bit harder to express that in the CRUD operations. And if you are using RPC, you can a lot easier to define these business operations in a more meaningful manner. But RPC can only be great and also useful for you if it is simple to use and interoperable across multiple platforms. And that's where gRPC comes in. At Google, internally, we use a framework called Stubby. That is the RPC framework that we use internally for all of our RPC codes. We make 10 to the 10 RPC codes per second. Now, just imagine if we're not using an efficient protocol for this case, right? Even forget about using text-based protocols. If we're just taking one extra byte that's unnecessary to transfer all of these requests, that's 10 to the 10 more bytes we have to shift around in the data center. So what happened then next is that Google was looking to open source Stubby, and another company called Square was looking for a next generation RPC framework as well. So what happened then is, they put together this thought and say, hey, why don't we open source, the next generation RPC protocol based on Stubby in a way, and let's call it gRPC. And that's what gRPC is. It's really taken from the ideas from many years of building services in technology companies, and where they're actually exporting all of this knowledge into this framework. Now, the G in gRPC does not stand for any companies I know that starts with the G. It actually is a recursive acronym. gRPC stands for gRPC, Remote Procedural Code Framework, right? That's what it is. It's fully open source. You can find it on GitHub, and anybody can contribute. It's got a great community around it, and that's what I'm here for. I hope people will continue to grow the community together. It is simple to use. It generates idiomatic stubs and clients. It's built to be performant and scalable and interoperable and extensible. And the reason that they can do that is because of some of the underlying technology that they use. They're using protobuffer 3 for the IDL, for defining the services, and also defining the message payload. They're using protobuffer 3, the binary protocol, the binary payloads, as the payload itself. So you get a lot of efficiency out of this protobuffer encoding, right? So everything there is binary. But what's more interesting is that this entire framework is built on top of the standard HTTP2 stack, okay? Which is really nice. If you never used HTTP2, here are a few things to kind of keep in mind. In HTTP2, everything is binary. So no longer can you telnet into a port 80 port, right? And then say get / whatever. No, you gotta have like a translator that can translate what you want to do into HTTP2 in binary encoding. What that also means is you no longer have to spend more bytes on the get, verbs or the put verbs and all that. They also do header compression. In some cases, if you ever introspect the message payload, there's going to be a lot of headers. And in some cases, your headers are going to be bigger than the message payload itself. In gRPC and over HTTP2, the headers are going to be compressed. But there's even more. It can multiplex multiple streams onto a single connection. So no longer do you need to really think about pipelining or opening up multiple connections to gain some more efficiency. You can multiplex multiple streams over the same connection. That also solves some of the issues like head blocking and stuff like that. But what's even more interesting is it can stream. It's native streaming. So again, you don't have to think about WebSockets anymore. Streaming is native in HTTP2. What that means is I can stream from the server to the client. I can also stream from the client to the server, and I can stream bidirectionally both ways. Okay. That's all built into the protocol. And there's other things like flow controls and a bunch of other details, right? Well, what's really neat is, like, for example, if you are requesting a page, index HTML, and in that page, the browser will want to download the CSS file or some of the images. You can actually proactively push those data to the client before the client even requests them. So, not only is it useful for RPC, it's really going to be changing the world on the web as well. Okay. So, how does that perform? There's a blog on the internet you can find that's published by Google Cloud Platform. But you can actually see the throughput differences between binary protocol versus a text protocol. But that's kind of expected, right? You kind of expect that. And I wouldn't be up here and say, what, it's going to perform the same between binary and text. That doesn't work. I mean, you're kind of expected. But I think what's more interesting, though, is the factor or the magnitudes of efficiency when you compare it to per CPU. And this is important. Because if you're moving into microservices world, and if you're looking into cloud native, or if you're even going to consider running on the cloud, guess what you're going to be charged on? CPUs, right? CPU cores. And of course, you want to optimize for that. So what that also means is, with gRPC, or the binary protocols, you're going to get more efficiency per CPU. Hopefully, that will make your process more efficient, and you can cut down on the other infrastructure costs. But another interesting fact here is, it actually runs efficiently on mobile devices as well. So if you're considering building a mobile app, consider a binary protocol, because it's going to be more efficient for the mobile applications on the smaller devices or even IoT devices, because they don't need as much CPU power to process these payload anymore. Okay? And also because the payload is smaller, they also have less data to transfer. gRPC supports multiple languages. C++, Objective-C, Node.js, and Java, and all that. But I want you to focus on just 3: Objective-C, C#, and Java. That's because these are the languages that you would otherwise use to build mobile applications. And safe to say, if you want to build a client in any of the 3 major platforms, you are able to do that with gRPC on the client side as well. Okay? So let's see it. Enough slides. Let me see my time right now. 2:15. OK, so I got some times. So what I'm going to do is to just show and tell on how you can actually build a simple service, a request and response. But then I'm going to move on later to using streaming to actually build a chat server that do bidirectional streaming. OK, so here's I have a simple project here. I'm going to start off with a simple server just so you get a feel of how that works. And there's absolutely just a few bootstrap code here in the pom.xml because I cannot possibly live code that because it gets too complicated. But what I'm going to do is I'm going to build a new service with gRPC. Now, the first thing I need to do is to define the IDL. Right? We talk about the interface definition language. You gotta do this first. There's no other way around it. And what I need to do is I need to create a new proto file. In this case, example services.proto. And what I can do is say, well, first of all, I need to make sure that the syntax is proto3, because the proto file could be containing proto2 definitions. You want to make sure this is proto file 3, OK? Just like Java applications or Java classes, you can put everything that you're going to define, the message payload and the service, in a package. So I can say, this is going to be com.example.grpc. That's my package. This IDL is going to be taken by a protobuf compiler, or more specifically, you think about it like a translation layer, right? It's going to translate this IDL and make a Java file out of it. And by default, it's going to generate a single Java file, and it's going to be a large file with every class in it. And if you don't like that, right, every compiler, you can, for every language, there are some additional options. So you can say like Java multiple files is equal to true. So there are different options you can use when you're translating the IDL into different languages. So with this option basically says, rather than giant files, you know what, go ahead and generate individual files, because that's what I prefer. Okay, and then, I'm sorry? A typo. Yes, thank you. Whew. Wait, that's still wrong, is it? Multiple. I can't spell. Thank you so much. Ooh, that was so close. Please watch out for issues. All right. And then the next thing I'm going to do is I'm going to define a message payload. And all I need to do is use the message keyword and say this is a request. You have to define the request and the response payload. And that will be translated to a class, ultimately, in Java, right, like a POJO almost. And then in here, you can specify different attributes, properties, fields, however you want to call it. For example, I can say I need a field called name, and here's strongly typed, so it's a string. And here's the thing you have to do. You have to give it a tag, a numerical tag. Why? Because protobuffer is binary. When it needs to marshal this into a binary payload, it needs to identify this field. And rather than using the name of the field, in this case will be 4 characters long, it's just going to send in the tag, this number, this numerical number, as the unique identifier for the field within this particular message type. Okay? And I can do int age is equal to 2, for example. What I can also do is I can do enumerations. So in Java, we have enums, so do gRPC and protobuffer. So I can do something like enum. I'm going to do sentiment. This is how good you are feeling right now, how you feel right now. I feel pretty happy so far. So I'm going to say happy is equal to 0. Yeah, hopefully, you could be very sleepy by now. So I'm going to say sleepy is equal to 1. And you could be extremely angry at me for having attending this session. So I'm going to say angry is equal to 2. Okay? So you can define however you want. And then just like Java enums, this is almost like a type you can use. So you can say sentiment is equal to 3. Okay? Now these tags, any tag values between 0 and 15 or 1 to 16, 1 to 15, sorry, is going to just take 1 byte, right? Okay, so we have that, and we can also do more complicated structures. So first of all, messages can be nested. So just like you can use classes to build a hierarchy, you can use messages to build a hierarchy as well. But you can also do a list of things, and that's what we call repeated. So you can say repeated string, small case, hobbies is equal to 4. Okay. And I can also do a map. I can have a strongly typed map. Again, just like in Java, I can have strongly typed keys and strongly typed value. And I'm going to say a bag of tricks, for example. Now, definitely, live coding is not in my bag of tricks, so I'm hoping everything works. All right? And yeah, so that's pretty much how you define something, a message. And I can do the same thing for response. So I can say hello response. And I can say string greeting is equal to 1, I think. OK. Now I have the request and response. Then I can go ahead and define the service itself. Right? And the way you do it, rather than using class, hello world service, whatever you say service, the name of the service, and rather than saying, public, void, whatever, you say RPC, greeting. You taking the input message, the request, and you have to say returns and the output. Okay? And now this is what we call a unary call, because you are giving it one request, you're returning one response, right? We can also make it streaming. What that means is if I have multiple hello requests, I want to stream to the server in a reactive fashion, I can say stream. If I want to stream it from the server to the client, all I have to do is to say stream here. If I want to stream in both directions, well, guess what? Stream in both sides. Okay? It will generate the right stuff for me. It's pretty straightforward, easy to understand. Right? So once I have this idea, then I'm almost there. What I can do next is to generate the actual files. And to generate the files, in a couple versions back, what you needed to do is to download this binary file. You have to know which version of that binary file and what architecture, what operating system you're doing. And then you're using it, and then download that binary file and run a very long, complicated command line to compile this into a Java code, and then you can finally consume it. Now, fortunately, we don't have to do that anymore, and that's why I like it a lot more right now. All you have to do is go to the gRPC GitHub page. They have all the dependencies here you can grab. So I'm using Maven. So I'm going to say dependencies. I'm going to put in the dependency here. That's just for the runtime, but for the build time, if I need to generate the stuff, since I'm using Maven, unfortunately, it's going to be a little long, so I'm going to put it here. Yeah. So what this does, this is a plugin I can use, right? And what it does is to basically say, hey, go ahead and figure out which operating system I'm running on and download the right native binaries for me. And then also tie it into my Maven build phase, compile phase, so that when I'm doing a compile, I'm also going to compile my proto buffer definition file, generate the class, and the Java files, right? So anyone here use Gradle? Gradle, yeah? All right, very cool. So Gradle, you have an easier time, I think, in some cases. This is all you need to do to kind of apply this auto generation. Any end users? No, it's OK. Well, for that, you may actually have to write your own task. I'm sorry. Makefile. I like to use Makefile myself for a lot of things. OK, cool. So that's it, right? So let me just go ahead and, oh, that's the target. So what I'm going to do is I'm going to clean it. OK, and I'm going to repackage it. OK. And if I go back to the target, if I go to generate a source, of course, I should be able to see protobuf, and I got all the files here. And because I say multiple files, what you're going to see is the multiple different types it's going to generate, and also the service stubs, and the client stubs, and all that is all generated for you. Okay? Now let's go implement the server. For that, I have to go back to that core page. I'm just kidding. No. For that, it's actually pretty straightforward. I'm not going to write 100 lines of code for this. In gRPC, the server is embedded. What that means is you actually have to write your own main method to start the server, right? So in gRPC, also in Java, everything is following the builder pattern. So you got to use, whenever you want to instantiate something, you cannot use new, just use the builder. So if you think of it now like a server, well, there's a server builder, OK? We'll see this repeatedly. And I'm going to listen on port 8080. And I'm going to add a service. This is where I register my service instance, this thing I want to serve. I can say I want to give it the new, oh, I haven't implemented the service yet, have I? So suppose I have implemented the service. I'm going to say greeting service impl. Right, that doesn't exist yet. And then I'm going to build it, OK? So now this is where I need to go ahead and create this service. I'm going to create this service under this package. Don't add it to the thing. Okay, and here, rather than implementing this interface, what I'm going to do is I'm going to extend greeting service import base. Okay, that's automatically generated for you, and then I can go ahead and implement the greeting method. Okay, and here's the interesting part. Remember the definition that we had, where it is a request and response. But now go back to this implementation. I mean, usually when I first got started with this, I was expecting something like a definition of hello response and hello request in the parameter, right? So what I'm trying to get to is I would expect that when I return a value to the client, I return it in the return value, right, type here, right? But in gRPC, on the server side, everything is implemented asynchronously. Okay, the client gets to choose whether the client wants to be blocked or not. On the server side, everything is asynchronous by default. What that means is here I can get a request, so I can print it out. So for example, out.println, they generate a toString for me as well, so I can print out the request. I can grab whatever I want from it, so I can say request.getName, for example, right? It's all generated for you. If I want to return something to the client, this is what I do. First of all, I need to create a response. Guess how you create a response? Yes, builders. So if there's a noun, there's a builder of some sort. Okay, so I can use the builder. I can set the greeting field. I can say hello and request.getName. Okay, I can build this. Once I have the response, because this is asynchronous, what you have to keep in mind is it'll give you a callback interface here, response observer. And it's got 3 different methods here: onNext, onArrow, and onCompleted. Does that look like something that you may have seen somewhere else? Yeah, like React, right? Reactive extensions, RX, right? It's very, very similar. They just have their own interface for it. So I can say something like, if I want to send one thing back to the client, I just say onNext. And, not complete yet, sorry, onNext. And the response, okay? Now be careful here. Because it is an asynchronous callback, you could very easily make mistakes like that, right? But the client is only expecting one thing. So if you do actually do this, we're going to catch it during the runtime, and you're going to get a runtime exception. So don't do it. But also, just like a string, if I just finish like this, my method code's done, the client will actually be hung because we did not call uncompleted, and so it's going to expect more things. Okay, so even in a unary case, you have to call uncompleted as well. Okay. Oh, what's going on here? Yeah, I think that's fine. Whew. All right. So now I have the implementation. I'm calling onComplete, and that's fine. So now I have the server. I built it. I register my service. I'm going to call it a server thing, and then I have to start it myself, so I can say server.start. And then, because the server is going to be running in the background, so if I don't wait for it, it's going to quit my main thread, so I need to do something like server await termination, just so I don't quit immediately. I don't stop my process immediately. Okay. I think that's it. I think that's really it. So I implemented the service, right? And then I implemented the server, which only took about a few lines of code. And let's run it. How many people think this will work? Oh, wow. Thank you. You know what? Thank you for your confidence. I think this is the most hands I've ever seen in my talks. Okay. So, so that's right. So I'm going to do a maven install Java, MySQL, not MySQL, sorry, my gRPC server. Oh, no. No, actually, I'm just kidding. This is actually running, right? Because I'm not printing anything. So the server is running behind the scenes. I'm awaiting termination. It should be listening for my request on the on port 8080. And the only way to find out for me at this point is to keep on going and make more mistakes in the client-side code. Okay? So let's keep going. All right. So how does the client work? This has nothing here, just a main method, right? For you to connect to the server, you gotta create a channel. In gRPC for Java, You don't have to deal with the underlying TCP connections. You don't have to know the underlying HTTP2 connections. You hide everything behind the concept of a channel. And to create a channel, what do? Yeah, exactly. Where did it go? Managed channel builder. Yeah. So you use a builder. For the address, localhost, 8080, right? Because I'm in dev, and we all know how sucky it is in Java to deal with SSL certificates, I'm going to say use plain text for now, right? And there are many other things you can set here, like executors, your own thread pools, for example. But a few interesting things here is the name resolver. So you can give it like a logical name of the service. And the resolver is responsible to return you a list of endpoints so you can do client-side load balancing. If you want to do client-side load balancing, then you can specify your own load balancer factory. So what I have in my sample code on GitHub is a name resolver that connects to Eureka, right? Through Eureka service discovery, I can get a list of the gRPC services I have, and then I can use the round-robin load balancer factory to do client-side load balancing. Okay, so I'm just going to build this. I'm going to introduce a variable called channel, right? So now I have a connection going to be established. Then what can I do is to generate the stub or consume the stub. And to do that, I think I do greeting service, gRPC, and I can create new stubs. Okay? And here, like I said, it is up to the client to decide whether the operation should be blocking or non-blocking. So the client gets to pick and choose the type of stub that they want to use, whether it's a blocking stub or a future stub. That means the return value is going to be encapsulating a future, or just a regular async stub, which you have to deal with the callback. Okay? So in this case, I'm going to do a blocking stub. I'm going to pass in the channel. Okay, and I'm going to stop. And if I do, I can say greeting, right? Then I can pass in the request. So I can do a new builder. So this is nice because all of the convenience builder methods is here. So I can say set name, I'm Ray. Set age, I'm 18, of course. And add hobbies, photography, right? And I can also put into my bag of tricks, live coding, right? Definitely not. Okay, I can't even type. All right, here we go. Okay, so that should be it. So that's going to connect, get my stub, send a request, and just so you know that this is being sent, I'm receiving something back. I'm going to get a response, and because there's toString implemented for you, I'm just going to go ahead and print out the response. Okay. Live coding. All right, how many people think this will work now? Yay! Now I'm guaranteed to fail. Oh, come on, please. Oh, yeah, it actually worked. Awesome. Whew. So you can see greeting here, right? On the server side, you can see I can print out everything as well, just for debugging purposes. This is kind of really nice. Okay, very cool. Now, that is a little bit too easy, right? You're like, yeah, you know, I can do that in less than a minute. Yes? But I took it slower. As you can see, I took it slow. So I'm going to do something even more interesting now. I'm going to implement a server, okay, for the chat. So what that means is I need to implement bidirectional streaming in this case, because once I connect, I want to be able to send data to the server and receive data back continuously. I don't want to poll, right? I don't want to do polling or anything. I just want to like have real streams. So what I can do there is I can go to I can go to my server code. And for this one, I'm not going to build everything from the scratch because you already know how you can create a proto file, right? So from this point on, the proto file is going to be pre-created. But one thing you should also take note is you can import from another proto file. Just like Java, you can import from another package or class, right? You can import from another proto file. Then you can consume the types from that proto file as well. So here I'm taking a timestamp type, and I'm going to put it here. I define two different types. The request is the thing I need to send to the server is the chat message, which has the from and the message. And then once the server receives it, it's going to put a timestamp on it, like when did I receive it, and then send the chat message back to all of the connected clients. Because it is streaming, so I'm adding the chat service. I have chat as the method. but then I have the streaming messages from the client to the server and streaming messages from the server to the client. The stub that it generates looks something like this. Okay. And this is a little mind-blowing at the first minute, but I'm going to try to walk you through this in a second, right? So because it is asynchronous, everything is done via the stream observer, okay, as the callbacks. Now here's the mind-blowing part of this whole thing is you see there's a stream observer in the request. In the input parameter, you see a stream observer in the return value. Now, now this is completely opposite from what we expect, but this makes complete sense, is that the client is going to give you a callback so you can stream data to it. And so for you to return the data to the client, you have to send it to something that they give you in the request parameter. Okay, does that make sense? Kinda, yeah? And the client is going to receive a stream observer from you so that they can call the onNext callback, right, and send data to you. So what that means is you're going to return a stream observer to the client, okay? So the return value is actually what you return to listen to the messages from the client. And so all of these onNext methods will be triggered when somebody sends you a message to the server, okay? So you need to handle the messages here inside of the server in the onNext callback here. And what that means is once I receive this, I need to, I'm adding this current client to a list of observers on the server. So for all of them, I'm going to, right, so all of the connected clients, I'm going to stream, use the for each in this case, and I'm going to say, onNext. And what I need to do is to send them the message that I received. So I'm broadcasting it to every connected client, right? And so for this, I need to define my chat message from the server, right? I need to build like a new payload that I want to return. And here, I'm going to make it easier. I'm just going to ignore the timestamp, and I'm going to just say chat message, okay? I'm going to introduce a local variable and just call it not build. Oh, no. I'm going to call it message, okay? So now, what I'm doing is I'm creating a single instance of this message that I want to send to the client, and then for every connected client, I'm going to send in the same message. Done, right? If there's ever an, oh, no, yeah, almost delete my code. Now, if there's any errors that you receive from the client, exception or whatever, I do what all Java developers do. When you catch an exception, do nothing. Same thing when uncompleted. Well, no, what I really need to do is to remove the current instance of the stream server so that I don't continue to send data to it, right? So if the client ever gets disconnected, I'm going to do this, okay? Whew. Yeah, let me get rid of that. Okay, so I think I'm done. Yeah, IntelliJ is not complaining. I'm in Java. I'm in type-safe environment. I feel safe. I think this should be fine, okay? Chat server, same thing. Server builder, start, await termination, done. Okay, that's a bi-directional streaming server just like that. All right, let's run this. I'm not even gonna ask this time, it's just gonna run it. Okay, good, I think it's running, right? It's fine, right? So now I can go ahead and implement the client. For the client, this is what I'm going to do. What I wanna do is run JavaFX. How many people here use JavaFX, by the way? Yeah, anyone? Okay, quite a few. SWT, AWT, Swing, still a few. Yeah, you can do all of that in here, in this context as well. Oh, shoot, let me go back. So this is what the application looks like. So ideally, I should say Ray and hello. If I press on send, it should send the data to the server. Obviously, it doesn't do that right now. So I'm going to show you how that bidirectional works in the client side, okay? So this was actually one of the first time for me to use JFX. I kind of like it quite a lot because all of these things are pretty straightforward. So this is the code to set up the view I just showed you. I'm not going to jump into this, but this is what I need to implement. Once the application is started, I need to listen to the button presses and listen to the incoming streams, right? So first, I establish a connection via a channel, just like I did before. I'm using an asynchronous stop this time because this is bidirectional streaming. This is async by nature. And what I can do is I can say chat service.chat. And for the input parameter, I need to give it a stream server, again. And guess what you get back? What do you get back? You get back a stream observer as well, okay? And you just have to really keep track of which observer are you talking to at this moment, right? Because they all sound the same, okay? So I'm going to say this is chat to server, okay? So this on next here in this callback, 10 minutes, is where I'm going to receive the on next, the message from the server. So whenever I receive something, I need to add it to, I need to display it in my JavaFX application. So what I do, I can, I have a list here. I can add the string, which is the chat message itself. So I'm going to say chat message from server. I'm going to get the message, get the from, right? And then maybe add a little IRC style colon, right? And then, the message itself. Okay. Now, because I'm in JavaFX, I need to execute this on the UI thread. So I think there's something called run later. And I can wrap everything in a runnable. And this will be executed. Whoa, two of these. This will be executed when it's back to the UI thread. Okay. On error, what do? You know the drill. Do nothing for now. And incomplete, I'm not going to do anything. No, actually, you know what? I should do something, but technically, you should be shutting down the channel. So you can do something like a channel dot shutdown, for example, shutdown now, and that will disconnect you as well. But you don't have to do that for now. Okay. Now, finally, when somebody click on that button, I need to do something, right? So what do? I have the send button. In JavaFX, I can do set on action. It will give you an event. And in this action, ooh, no, okay. I don't want to redo everything all over again. All right, so in this action, when somebody presses the button, you need to send the data to the server. What do? Well, you have the chat message, right? And what do? You do the new builder. You build it. You set the from with the name, right? That's the named field. And you can set the message from the message field. Okay, I can set this to message variable, and then I can send it to the server. How do I send it to the server? How do I do that? Through the observer, right? So there's a chat to server observer. I can call on next. Oh, no, don't complete it. On next. And the message. Okay. All right, so I think that's it. Let me see my notes. I think that's really it, yeah? So here, again, just a recap. I'm listening for data streaming to me from server to the client side. And whenever I receive something, I add it to the UI. And then when somebody presses the send button, I'm going to receive, generate the message and stream it to the server. That's really it. It's all on next interface here. All right, let me see a show of hands. How many people think this will work? A little bit more, yeah. I'm sorry to disappoint you in a second, yeah. So let's try it. So this is the moment of truth. I'm going to say hello, Ray, and say hello, JFocus. This is really stressful, Oh, it works. All right. Whew. Whew. Thank you. Now, it actually doesn't mean it's working properly because it's only one client. So I'm going to say, I'm going to run another client. Every time I do this demo, my heart pounds really hard. Just boom, boom, boom. All right. So I know, Felipe, are you here? Felipe Hoffa, my awesome colleague from Google Cloud DA team. Felipe is in the room. So Felipe, I'm going to say something on behalf of you. I'm going to say, great job, Ray. He never gives me any compliments. I'm just kidding. He always do. So I'm going to say, great job, Ray. And, of course, he shows up on the other side, right? And I'm going to be like, why? Thank you. How nice. Felipe. And now you have bidirectional streaming from client side to server and server side to client. Now, of course, I took some time to write this, just to be able to show you, all the steps that it takes to do it. But when you really think about it, when you look at the code, it makes a lot of sense, and it's actually quite condensed, very concrete, and you don't actually end up writing a lot of code. Now, what I'm going to do next is to show you just one more thing. How much more time? 5 minutes? Okay. I'm going to show you one more thing. By the way, this is what I do when I'm done with a talk. I do reset. I should say hard. Yeah, I think that should be it. And then I go git branch. Oh, I also do checkout dot, right? So I check everything out. So all my code gets wiped away boom, I got to do this over again. But then what I do is, get checkout master. I want to show you this really interesting code. Because remember that stream observer? It looks a lot like a reactive extension type code, right? So I thought, hey, wouldn't it be nice to be able to deal with the streams in a reactive way? So you can actually do it. And I got some help in one of the conferences. I think it was Mark who helped me out. Let me see if I can find the client here. Give me 1 second. Yeah, so here's the client. So, right, this is the asynchronous client that we just implemented. Right, you gotta deal with the stream observers. You gotta deal with the unnext callbacks and all that stuff. Right. So what happened then is that, hey, Mark, can you actually help me out and say how do I actually consume this in an RX fashion? Because I like the RX semantics, right? I like to use the map or the for each or whatever, subscribe. And the answer was, yeah, you actually can't do it. But you do have to write a little glue code. So here I have a RX client that takes in the channel, right? And then I can call the collect method. But check this out. What is metrics? What is metrics? That's a good question. What is metrics? Where did I define it? Oh, there we go. It's observable, right? It's observable of long. So I'm streaming like 1, 2, 3, 4, 5 to the server. And then the server is going to stream something back. In this case, it's going to take averages of whatever. It's going to stream back the average every 10 or 20 metrics that I send to the server. Right? Think about IoT devices where you are constantly sending temperatures and you need to get an average of some sort from the server also constantly. So now, this collect method is going to return me a observable. Then I can do all the maps and do all the RX Java magic on it if I want to. Now, here's the trick. For you to implement it, you have to implement something called unsubscribe. At least in RX Java 1, this is what you needed to do. And it was, I think Mark helped me out. And you can find him on Twitter as well. And what that means is you got to implement the subscriber interface, and you need to kind of deal with this little connection between RX Java and gRPC on next, right? So there's a little trick to it, but it's pretty straightforward. In RX Java 2, I think it got actually a lot easier because they have a new construct for you to create observables easily, okay? Let me go back to the slide. I don't think I have a lot of time, so let me go back. So I talked about that one more thing. There's a lot more to this. There's a lot more. I talked about streaming. There's actually deadlines. What that means is if you are making multiple calls to multiple services, if you're going multiple nested service calls, but you have an SLA to meet. You got an SLA. You don't want to block the user forever, right? You can say like, hey, if I don't get any response back for like a second, forget about it. I'm going to move on, or I'm going to just cancel everything. So you can set deadlines, and the deadlines can be propagated throughout the entire call. What that means is if I'm having a deadline of 1 second, and the first call took half a second, well, the subsequent calls can only have half a second total to make the entire round trip back to you, right? And you can propagate the deadlines. You can also add metadata like headers into your code, so you can add in some like JWT tokens or any other authentication tokens you need to add. You can also propagate context across multiple service calls, and it's usually all pretty easy to do. So for example, if I go to my client, here I have a stop. This is the fully written one, right? If I need to set a deadline on this call, all I need to do is to say, hey, stop dot with a deadline, right? And then after 1, you need to give it a time unit. Usually I give it like 1 day, right? and then this call will have 1 day to complete, right? Of course, you don't do that, so you can give it a different time unit, of course. Okay, and there's a lot more to it. You can do load balancing. You can hook it up to the server registry if I want to. I got sample code on GitHub. Health checking, security authorization, and you can tie it into distributed tracing like Zipcan pretty easily. There's a really nice client, and you can use Prometheus. Again, there's a pre-made thing you can just hook into gRPC, and all of a sudden it's exporting metrics for you. All right? So, again, the reason I'm here is like I want to show you something new, something different, and also I want to get your contributions and getting you to participate in this awesome community. So please check it out. Go to grpc.io to see how you can contribute and try it out. and join the community. Now, one last thing I just want to show you, on gRPC.io, there's an About page. And if you scroll down a little bit, you can see some of the users and their feedback on how they're using gRPC today. Okay, so check it out, and thank you very much for your time. Really appreciate it. Thank you. Got time for questions? I don't know. Yeah, if there are any questions, I'd be happy to take it. Sorry, he was first. Sorry.
How do you share a proto file between the client and the server?
How do you share the proto file between the client and the server? You can do it 2 ways. One is share only the proto file and generate on the client again to regenerate it. The other way is to generate a package. Then you share the generated clients and the stubs via the package. There are 2 different ways. Now, remember, in proto files, it's actually the payload that they generate is backwards compatible. That's what you want, actually. And there are different best practices in terms of adding fields and removing fields. So you gotta be careful with that. And if that's the case, then your app is going to, your service is going to work as you upgrade. Now, I don't know what this is. Is that a phishing thing, or should I type in my password? No. You know what? I'm gonna do that later. There's another question. Any other questions?
Does when the server changes the proto file, can the client detect that?
When the server changes the proto file, can the client detect it? The short answer is no, right? There's no notification built in to say, hey, my protocol is different now, so client, go ahead and update. However, update automatically, right? However, if the server did add a new field, the client can still consume it, which is fine. It's going to ignore the new field and continue to work. Right.
Another question.
Yeah.
What about we love using Postman and curl for testing our servers?
Yes.
Is that history now?
Yeah, that wouldn't work anymore. But there is a gRPC CLI of some sort that you can use. I don't know if I'm going to regret showing this, but this is an npm package. But this is good. So you can basically connect with the proto file so that the payload format. You can connect to the host, and you can give the payload in a JSON format. It's going to convert it for you. Okay. So you can still do some of the things that we used to do from the command line, just not with curl. Okay. So I think that's all the time I have. So thank you again for attending this session. Thank you.